Hi guys, so today we're going to look at DeMoivre's theorem and we're going to approach it using a shortcut. So the formula is wonderful, however, it can get a little intense. So 3 steps to using DeMoivre's theorem with a shortcut is the first step is that you'll find the root of the modulus. So the modulus is just the value of r. It's outside of the parentheses when the complex number is in trig form. When it says to find the root, so I put a little, table here of roots. So square root is nothing more than a power of 1/2. If you're looking for a cube root, that's just a power of 1/3. And if something has a fourth root, that means it has a power of 1/4. So just something to keep in mind. Once we're done, we'll divide the angle by the index of the root. So just kind of keep in mind, if they ask for the cube root or the third root, you divide by 3. Fourth root, you'll divide by 4, so on and so forth. And then from there, divide 360 by the index of the root. So we're going to apply this into this example. Find the cube roots of 8 times cosine 135 plus I sine of 135. This complex number is in trig form. So starting off, I'm going to color coordinate the steps. We're going to find the root of the modulus. So since they're asking for the cube root, again, I'm going to take the cube root of the value of r, which is the number outside of the parentheses, that would be 8. So cube root of 8 just means I'm looking for a number that multiplies by itself 3 times to be 8. This can also be seen as 8 to the 1/3 power. Just a note, if you're going to plug this into the calculator, make sure that you type in 8 to the, and in one parentheses, 1 divided by 3. And that should give you 2. So first step, the root of the modulus, in our case, is going to be 2. And then from here, we're going to divide the angle by the index of the root. So keep in mind that the index of the root will change depending on the question. So in this case, they're asking for the cube root, which means we're going to divide the angle by 3. So if it says fourth root, you'll divide by 4, but since it says cube roots, we're dividing by 3. 135 divided by 3 gives me 45 degrees. And then from here, I'm going to take 360 degrees and divide it by the index of the root. Again, the index of the root changes depending on what question we're given, because sometimes they ask for fourth roots, fifth roots. So in this case, since they're asking for cube roots, the index of the root would be 3. And keep in mind that since the angle is given in degrees, that's why I'm dividing 360 by the index of the root. If this was in radians, I would divide 2 pi. So make sure the angles correlate as well. So 360 divided by 3 is 120 degrees. Well, that's great. Now what do I do with these 3 things? So keep in mind, when you're asked for cube roots, you'll have 3 answers. If you're asked for the fourth root, you'll have 4 answers, so on and so forth. So in the formula, with cube roots, you would apply k equals 0, k equals to 1, and k equals to 2, and that would give you your 3 answers. So instead of using the formulas, I'm going to use these 3 things that I just solved and apply it into writing the complex number in trig form now. So I'm going to write 2, and then cosine of the first angle that I just found, 45 degrees, plus I sine of 45 degrees. So this is what happens if you plugged in k equals 0 into DeMoivre's theorem. You would get 2 cosine 45 degrees plus I sine of 45 degrees. Now the good thing is that the root of the modulus will never change in your answer. So this will be 2, even if they ask for the 10th roots, which they won't, but I'm just saying. So this will remain 2 the whole time. The only thing that changes is going to be the angle. So what do I do with the angle if I don't want to have to keep applying k equals to 1, then k equals to 2 into that whole formula? Well, that's what step 3 would be for. So notice that it's 120. So I'm just going to add 120 to each angle for each root that I get. So from here, 45 plus 120 would give me 165 plus I sine of 165. Again, the root of the modulus stays the same, and then cosine of 165 plus 120 would give me 285 plus I sine of 285 degrees. And that's it. Those are your cube roots. All right, guys, I hope this helps.